Now in this project we also want to consider a very important pulse shape in communication systems called the raised cosine pulse shape. And typically this looks like a sinc function with the tails all squashed down. So maybe you get one negative undulation and just a bit, and then it tapers to zero pretty fast. In the frequency domain, it has this characteristic shape of a constant in the middle, and then that so-called raised cosine on either end. That's the name of that curved region. B sub 0 is called the minimum Nyquist bandwidth. That corresponds to the bit rate over 2. And this little bit of a tail extension here is given by the factor alpha. So the bandwidth is extended just a bit by this factor alpha, which is called the excess bandwidth factor, also called the roll-off factor sometimes. But the neat thing about the raised cosine pulse shape is that the vast majority of the energy is contained within about B sub 0. We do not have the long tail extension as we find for the sinc function. A little bit of extra bandwidth, but certainly it doesn't persist for a long time. After modulation then, we find that the bandwidth can be considered pretty much twice that bit rate over 2, so we could call that just simply the bit rate. Again, recognizing that with that tail extension it goes just a little bit beyond that. But this is a very spectrally efficient pulse shape in the frequency domain.